Well, howdy there, Internet students. It's Mr. Hermanson again. Today we are going to learn about mathematical similarity. And here's just a quick little idea about what similarity is. If you enlarge a picture, you want that picture to look like the original, just bigger. Or if you shrink something, you want it to look like the original, but smaller. Well, that's what similarity is. Okay. Now, if you create the picture here, maybe I can do it quick here. Just use my snipper, and I'll take a picture of this, kind of show you what I mean. All right. So I just made that larger, but I have the same proportions. She really looks the same. The fish looks the same. Now, if I shrink it up by grabbing the corner like that, she will still look the same. Okay, just a larger version. All right. So it looks like, but notice how the one on the left doesn't really look the same. It seems like she was shrunk, but only squished together the way it was shrunk. And the middle one, she was shortened, but it's still just as wide as the original. Okay, now here's how we're going to define that. We're going to define mathematical similarity as the ratio of the length to the width, or the height to the width, however you want to look at that, is the same as the original. That there's some scale factor that we changed both dimensions by. If you just were to take and make it wider, but not make it any taller, then it wouldn't be similarity. You would end up with something like the middle picture here. Okay? If you made her taller but not any wider, you would end up with something like this first picture here, where she's just kind of stretched out and she doesn't really look the same anymore. Okay? So what we want to see is that the height to width ratio is the same as the original. And if we look at these, this first one, 10 to 8, I can simplify that. That's the same as 5 over 4. This is 8 over 3. This is 3 over 6, which is 1/2. And the last one is 5 over 4. If they simplify to the same ratio, then they are mathematically similar. All right, so that's the idea, just a definition of similarity. Okay, now we're going to see what happens when we do certain rules on characters. Now, if the object is a WUMP, then it's mathematically similar to Mug. Okay, so we're wondering if Zug is actually related to Mug. In other words, is he mathematically similar? Okay. What you're going to do is create these new points. This first one is 2 times x, 2 times y. So you have to do 2 times 0, which is 2. 2 times 1 is 2. 2 times 2 is 4. 2. So you're going to fill in all these points, and then you're going to graph Zug on the next page. Okay? I think we're going to make Mug 2 first. So Mug is our original character. He's going to go here, and then we're going to make some other ones. All right. But what we can do is go ahead and fill in all these charts with the rules. Let's just make sure you have these first ones right. So go ahead and fill in all these using the rule for Zug, which is 2x, 2y. All right, now we're going to start drawing Mug. Mug is the original xy, so 0, 1 is a point. That's right there. Start there. 0, 1, 2, 1. 2, 0. 3, 0. 3, 1. 5, 1. 5, 0. And we kind of want to connect these points as we go. All right, I'm going to let you do that. Continue that to create Mug. All right, so here's what your mug should look like. Now we're going to create the next person, which is Zug. And remember that rule is all the coordinates are double. So let's see what happens when we do that. We'll put Zug down here on this graph. Go ahead and graph this set of points now. All right, so if you graphed it correctly, this is what Zug looks like. Okay. Now, what we want to know, is Zug a WUMP? He's a WUMP if he is similar to the original. Oops, that got moved a little bit. In other words, is his ratio of height to width the same as the original? If it is, then he's a Zug. Okay, I'll let you think about that for a second. We're going to move on to the next page. We're gonna find the coordinates of some new game characters. We're not sure if they're WUMPs or not, but we're going to go ahead and find the coordinates of Lug and Bug. Lug, you're going to multiply the x by 3, but leave the y the same. Bug, you're going to multiply both of them by 3. Go ahead and do that. You can check your answers here. Pause it now if you're checking. All right, now we are going to enter those coordinates onto this page. All right, if you did it right, that's what Lug looks like. Now I'm going to drop Bug. All right, there's what Bug looks like. We're going to do one more. We're going to do Glug. And you're going to get that by multiplying Mug's coordinates by leaving x the same and multiplying the y coordinate by 3. Here's what those coordinates look like. And we're going to graph Glug. All right, here's what Glug should look like. All right, now we're going to answer some questions. Are the figures mathematically similar? Yes, if the corresponding angles are the same measure, congruent, and corresponding sides have a scale factor. So go back and look at your pictures of Mug and Zug and see if they are mathematically similar. Okay, so make a guess. Do it in pencil in case you get it wrong. All right, you should have said yes to that. The corresponding sides have a scale factor. It's 2 to 1. If the fractions are equal, then the number is a scale factor. Yeah, this equals 2 or 2 over 1, and so does this. And that's a scale factor. Some people like to say times 2. So Zug is 2 times Mug's width and 2 times Mug's height. So if they are mathematically similar, then Zug is a WUMP. Zug is a WUMP with a scale factor of 2. Or Zug is an imposter. Are Mug and Lug mathematically similar? Go ahead and check that out. So Lug's width is 24, Mug's is 8. Lug's height is 7, Mug's height is 7. Lug is an imposter. They have different scale factors, and the angles, if you look closely, aren't really the same. All right, so next thing we're going to check out is Mug and Bug. Are they mathematically similar? Check that out. You should have found that they are mathematically similar. Bug is a WUMP, and the scale factor is 3. How about Mug and Glug? All right, so Glug is an imposter. They have different scale factors. The characters of the WUMPs, that would be Zug, WUMP, and Mug. No, Mug was the original, sorry. Who was the last? Bugs. All right. Zug had a scale factor of 2 and Bug had a scale factor of 3. Now you'll notice that those are in the rules right next to the letter when you make the rule. You'll see for Zug 2 in front of the X and in front of the Y, that you have the same number in front of both. It seems like if you have the same number in front of both, that will make them mathematically similar. All right. Hey, that's all I got for you today. Go ahead and do the assignment, and we'll talk about this in our next class. Have a good day.